It's often useful in math and physics to be able to add vectors together. Uh, so let's take a look at an example of a problem where we would do that. Let's say a man walks 2.5 miles at west by 22 degrees north, then jogs 3 miles, 3.0 miles at north by 35 degrees east. How far is he from his original position, and in what direction? Now, first of all, the answer is not 5.5 miles. You can't just add these two distances. If we draw this out, 2.5 miles west by 22 degrees north, that means that this angle is 22 degrees. That means that this is 2.5 miles, and then from there, north by 35 degrees east, he goes 3 miles. Then our resultant vector is that guy right here, running from the origin to his final destination. So we can't just add the magnitudes together. That won't tell us how far away we are. That only works if the vectors are pointing in exactly the same direction. But in order to add these, so he's gone, with this first vector, he's gone some amount west. With the second vector, he's gone some amount east. And if we add those together, we'll find out how far west he's gone total. And then with this vector, he went some amount north. And then with this vector, he went a further distance north. So if we put together how far north each vector is, we can get the total northness of the resultant vector. So if we look at this vector first, we got 2.5 miles at west by 22 degrees north. Well, if we want to find the x component of that vector, we'll need to use cosine. Cosine of 22 would be the x component over 2.5. So the x component is going to be 2.5 times cosine 22. Since it's to the west, we will call that negative. And then the north component, the sine of 22, opposite over hypotenuse, would be the y component over 2.5. So the y component of that vector is going to be 2.5 sine 22. For this vector, 3 miles at north by 35 degrees east, well, now notice that in this case north is first, in this case north was second. That switches things around a bit. So north by 35 degrees east, we look at this, the x component now is opposite the 35. So we can say that that is 3.0 sine 35. Alternately, you could figure out that this angle is 90 minus 35, which is 55. So you could say 3.0 cosine 55, because then this side would be adjacent to the 55 degree angle. And then the vertical component is adjacent to this angle, so cosine of 35 would be the y component over the hypotenuse, which is 3. So 3.0 cosine 35 is your y component there. And once we have components, now we can just add. We can add together x components, add together y components, and that will get us the x and y components of the resultant. So I will break out my calculator here. And I'll tell you, make sure I'm in degree mode, because I have to be in degree mode, otherwise it won't work out properly, because I'll be doing my calculation in radians. Like negative 2.5 cosine 22 plus 3 sine 35. Now that is the y component of my vector. Rather than writing down 7 decimal places, I jot down a couple and dot, dot, dot. But then what I like to do is I store that value. There's this store button, STO arrow, on the 8384 model. There's a similar button on the 89. Press store, and then you type a a letter. If you hit alpha, you can get any letter you want to. Since it's the x component of the vector, I will call it x. And now, if I type x, that will pop back up. Then we need to get the y component. We're adding together the y components of each of our two vectors. So I take 2.5 sine 22 plus 3.0 cosine 35. The calculator tells me that's 3.39. And I will store that as y, since it is the y component of the vector. So now we have the x and y components of the vector. But anytime you give an answer throughout this whole class, I'm going to want the magnitude and direction of the vector. So if I have this stored as x, have this stored as y. When you have the two components to find the magnitude, remember, you just use Pythagorean theorem. The magnitude of my vector is going to be square root of the x component squared plus y component squared. And since I have those values stored in my calculator, I can type square root of x squared plus y squared. And now I can see that my vector has a magnitude 3.446. Our original values have 2 sig figs, so we'll call that 3.4 miles. And then we need our direction angle. Recall, to find direction angle, we use inverse tangent. Take the inverse tangent of the y component over the x component. My calculator tells me that's 80.019 degrees. You can just ignore the negative because that's telling you what quadrant it's in, but you know that already. Let me just get this down, 2 sig figs, so that's 80 point degrees. And then you look back at your components, we know, since the x component is negative, the y component is positive, that our resultant vector, is somewhere over here, which tells us that the angle we just calculated, inverse tangent of y over x, tangent is opposite over adjacent, so that's this angle, which is starting from the west and rotating toward the north. Therefore, we can say that is west by 80 degrees north. Sorry, I drew this vector poorly. The x component is smaller than the y component, so it's really more up here. I was thinking slightly backwards when I drew that. And so then that is your answer. This guy has walked 3.4 miles at west by 80 degrees north. We can do this in another way. We could go, say, in terms of forces. We say 2 men are pushing a wardrobe across the floor. One pushes with a force of 150 newtons at east by 22 degrees north. The other pushes with a force of 210 newtons at east by 31 degrees north. What is the resultant force? Resultant is the term that's typically used with force. It just means how much total force is there. So again, we're going to go through the same process. Now both of these are east by north. They're going to have positive components, and we're given east first, so we can use cosine for the x component, sine for the y component. So 150 newtons at east by 22 degrees north in component form. That would be 150 cosine 22, 150 sine 22. 210 newtons at east by 31 degrees north would be 210 cosine 31, 210 sine 31. We add those together. Here we have 150 cosine 22 plus 210 cosine 31. 319, store that as x. And then our y component is going to be 150 sine 22 plus 210 sine 31. That comes out to 164 point something. I'm going to store that as y. And then the magnitude of my vector, again, is square root of x squared plus y squared. And as always, we're not rounding anything until we get to our answer. 358.9, 2 sig figs. That would round then to the tens place, which would be 360 newtons. And we take inverse tangent of the y component over the x component, which gives us 27.25 degrees. 2 sig figs, that's 27 degrees. Positive x component, positive y component, that tells us we're off over here. We found this angle, so that's starting at east, rotating toward the north, so that is east by 27 degrees north. That is the magnitude and direction of that vector. So anytime, just to summarize the process, anytime we're adding two vectors or subtracting vectors for that matter, first we turn our vectors into components. Then we add x components, add y components, add x components together, add the y components together. That's what we did right here. And then turn the resultant components back into magnitude and direction.